Today, we're going to see how do we identify key properties whenever a graph is being given. Now, in order for us to fully describe a graph, we need to know some key properties. Know that there's a lot of properties of those, like many graphs that we're going to look. But as of today, we're just going to look at the following properties. We're going to see what is the degree of a function. We're going to see how can we find the max or minimum, which there are two types, either an absolute or relative. We're going to see how can we identify the x-intercept, and we're going to see what is the domain. Okay, so at least for right now, we need to know these four properties in order to describe a graph. Okay, so to describe a graph, we need to know these four properties. So let's look at some examples here. Now, let's say you've been given this graph. Now, in this graph, let's try to identify one property at a time. Let's try to see what is the degree of a function. Now, the degree of a function, it depends on how many solutions your graph has most of the time. No, this is not always true, but at least for the examples that are going to be seen, it is true. So look as to how many solutions we have. Remember, your solutions are on the x-axis. So I see that I have one solution here. I see that I have another solution here. I have two solutions. So what does that mean? That means that my degree of a function is second degree, because I have two solutions here. So that was pretty straightforward. Now, let's look. What is the max or a min? Well, look at your graph. Try to identify, can you spot the highest point? Can you identify the highest or the lowest point? Well, I see that in here. The highest point is right here. Now, that highest point, we're going to call it a max. If it would be in the lowest point, that's called a min. So right now, the highest point is being called a max. Know that we have two types of maximum or minimum. We have either an absolute or a relative. Now, here, we know that this is the end of the graph, and this is where it starts. Oh, the other way. This is where it starts, and this is where it ends. So we can see that this is the whole graph. So we know that there is no other high point in your graph, because this is where it starts, this is where it ends, because we have points here at the end of our graph. So this is our overall picture. That is the highest point that you can see on your picture. So that means that we have an absolute, because there is no other point in your graph that is higher than that point. So we have an absolute max. Okay. Now, to look for the x-intercepts, we already found them. So our x-intercept is when x is equals to -4, and when x is 0, which we can also think of this as our solutions. Now, the domain is just another point, it's just another word to say, what are my x values? What are my x values in my graph? So when you think about domain, you think about x values. What are my x values in this graph? Well, let's see. I know that my graph starts like this, starts at this point, and I know my graph ends at this point. So what are the x values that my graph uses? Well, I know that it starts around this point. I know that it ends at this point. So my domain is going to be from this x value to this x value. Now, what is my x value here? We're going to call that negative. So my domain is going to be from -4.5, because that is the x value that you start with. And now, what is the x value that you end up in? Around 0.5 to 0.5. So this is one way for you to think about domain, but we're going to be using set notation. So in order for you to write domain, we're going to use close bracket. So from -4.5, comma, which should indicate as to where, to 0.5. Okay, so this is a notation that we'll be using for domain, where a bracket, square bracket, it means that we're going to be using that point, and we're going to be using the next example as to when do we use the open bracket. Now, let's look at our next graph here. Again, let's look at some points here. Let's identify the degree of a function. Basically, how many solutions do we have? I have one solution here. I have another solution here. So that means that we have a second degree. Okay, because we have two solutions. Now, max or min, well, we gotta be careful here, because I see that this is the lowest point in our graph. But now, notice the ends. Now we have an arrow here. So that means that our graph, it doesn't stop here. It actually continues. So it continues. But now look at your graph. It continues always upward, always upward. So do you think there's going to be a lowest point on this one? I don't think so, because your graph's always going to be upward, upward. So is this the lowest point that your graph can reach? Yes. So we're going to have a minimum. And is this the lowest point that your graph can reach? Yes. So we have to have a maximum, an absolute minimum. So an absolute minimum. Now, for the x-intercept, we already found them. So x-intercept is x negative 1, x is 3, which again, we can call that our solutions. Now our domain, this is where it gets tricky. We said that our graph continues going all the way up, all the way up. So this is a common mistake. Your graph does not end up here. Your graph is not between these 2 points, because we have some arrows which says that my graph is still going to continue all the way to the right, and my graph is still going to continue all the way to the left. So how can we put that into set notation? Well, we're going to say that our domain is from negative infinity to positive infinity, because we can use infinite many points on the left side, and we can also use infinite numbers on the right side. So our graph goes from negative infinity, it goes down, 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 and then it's going to go all the way to positive infinity. Let's look at another example here. Now, again, how do we find the degree of a function? We're going to look as to how many solutions do I have, or how many x-axis, how many points are touching my x-axis. So we have 3 points, so my degree is a third degree. Okay, now identify the max and the min. Let's do it one at a time. So now notice that, let's look at this point. Let's look at the easy one. Let's look at this one. So I see that this is where it changes direction. I see that this is the minimum point, because it goes from here and then it starts shooting up. So this is a minimum point. It is a low point. Now, is this the lowest point in our graph? No. I mean, look at this point here. They're definitely lower than this point. So it's a low point. It's not the lowest point. So this point, we're gonna call that a relative minimum. So we have a relative minimum, which I did in blue. Now, let's look at this point. You see where it changes directions here? That's a maximum. But now, is this the highest point that your graph can reach? No, like, we have more points here on the right side. So this is not an absolute maximum, but a relative maximum, because it is still a maximum, because that is where your graph is changing direction. But is that the highest point that your graph can reach? No. We have other points here on the right. So we're going to call that a relative minimum. Okay, so we have a relative maximum in blue here, and we have a relative minimum. What did I say minimum? That's a maximum. Sorry. relative maximum at this point, because that's a high point, not a low point. Alright, so now going back, let's identify my x-intercepts. Again, we have them right here. 2, 3. So let's place that. We have an x at -2, which is this point. We have another x-intercept at -1, -1, and we have another point at +1. Okay, which again, those points that touch your x-axis are also called your solutions. Now, what is my domain? You gotta look at the overall picture. Does your graph even stop? Nope. You see that there's 2 arrows at the end. Now, how do I know they're arrows? Because when they don't put your points at the end of the graph, so if I put points here, that means that my graph actually starts here and actually stops here. If you don't see any kind of points, if you don't see any kind of points at the end of your graph, then that means that your graph is still going to continue. So sometimes they put an arrow, sometimes they don't, or they should put an arrow. So if you don't see a point there, there's an arrow there. And if there's an arrow there, it says that your graph is still going to continue moving this way, all the way. And this part is going to continue moving all the way there. So that means that what are the x points? What are the x points that your graph can reach? Well, we see that if it's extending here, it's going to go all the way to -infinity. So it goes from -infinity. And if my graph continues moving to the right, it goes all the way to +infinity. So my domain is -infinity to +infinity. Now here's your entrance ticket. Again, here's a graph. I want you to identify the key properties, which is the degree of the function, maximum, minimum, x-intercept, and the domain. Now, one thing that we're going to let you know is notice that there's some points on the end of the graph. What do they mean? Well, look at the previous example. What do they mean whenever we have points at the end of the graph? Just a hint, that should help you with the domain.